Hello students, myself Manojit Dey and I am your physics teacher. Today is the fourth day of this chapter, that is motion. So yesterday we discussed that how to draw a graph from the data and how to calculate the acceleration and velocity and displacement from the graph. So today I am going to explain you three equations of motion of this chapter. So by these three equations of motion you can actually do any numericals of this chapter. And first I write the three equations of motion and then I am going to explain and derive how to derive those equations of motion from the graph. So without wasting time, let's watch our video. So students, these are the equations of motion. So first equation of motion is v equals to u plus at. This equation denotes the relation between the velocity and the time. The second equation is s equals to ut plus half at square. This equation denotes the distance or displacement and time relation. And the third equation of motion is v square minus u square equals to 2as, which is represent as the relation between velocity and as well as the displacement. So let's derive these three equations from the graph. So first we are going to derive this equation, then one by one we are going to derive. So student, to derive these three equations of motion, you have to understand an example. Suppose your friend suppose is standing on this position A, okay, standing this position A, and he start moving towards the point that is C, okay. So this way he is going to the point C. Now suppose you are here and you observe your friend's motion. So when your friend is in A, his velocity is u, that will be the initial velocity, and as you start observing from that A point, that means here time is equal to 0, and here also time equals to will be t. T can be any number, that will be 10 minutes or 15 minutes. So here I consider that is t, and the final velocity will be v. So how to draw this graph on a velocity, how to draw this motion in a velocity time graph? So to draw velocity time graph, see, the first point will be t equals to 0 and velocity equals to u. So at t, so you can see that there is a y-axis and x-axis. So x-axis represents the time and y-axis represents the velocity. So at t equals to 0, so we can consider that this point will be 0. So at t equals to 0, velocity will be not 0. If velocity is 0, we are putting the point here, but here velocity is not 0, so velocity is u. So we can consider that this point is u. So the height will be u, right? Height will be u. And the second point we get that at time equals to t, so we can consider that this point is t. This point is t, that means this distance is t, okay? This distance is t, and at that point the velocity is v. So velocity, suppose we are getting that velocity v is here. So this point meets here. So this will be the second point and this will be the first point, right? Now we have to draw the line from this point to this point. So this will be the straight line. So this will be the straight line, and see, the graph is look like this. So from the graph we have to calculate that equation of motion. So how to calculate the equation of motion? To derive this equation of motion, we have to draw some imaginary line from this to this, and we have to note some points. Suppose this is A, this is B, this is C, sorry, this will be C, this will be D, and it's O, okay, the origin. So here you can see that OA, B, C, D will be a trapezium, right? This is a trapezium. So now from that graph, how to calculate, this is a velocity time graph, so how to calculate the accelerations from velocity time graph? To calculate the acceleration, we have to draw the slope. So how to draw the slope? Here you can see the slope means the triangle of that velocity time graph. So if the graph is look like this, what will be the triangle of that? So you can see that ACB, that means ACB is the triangle here. ACB is the triangle here. And how to calculate the acceleration from the slope? The height by the base. When we divide the height with the base, we get the actual result of the slope, that is acceleration. So to do that, we have to write that acceleration A equals to the height, that means BC by AC. So see, what will be the result of BC? Acha, this will be V. Okay, see here, the height is V. So what will be BC? BC will be V minus U, right? As this height is U, so we have to this height is U, right? This height is U, this one. So the height of the BC will be V minus U. So we have to write that BC is equal to V minus U by AC. What is AC? AC is, here is A and here is C. So this length is equal to this length. So this one is T. So we can get V minus U equals to T. So A equals to V minus U by T. And from that equation, we can write that AT equals to V minus U and V equals to U plus AT. So this will be the first equation of motion. This will be the first equation of motion. Okay. Now we are going to derive the second equation of motion. Now students, we are going to derive this second equation of motion, that is S equals to half AT square. So to calculate the displacement from the velocity time graph, we know that we have to draw the area under the curve. That means here the curve is curve means the actual line. So we are going to derive the displacement, so that we have to draw the area of that under this curve. So what will be the area? See, as this one is this line will be the graph, so the area under this is this area, right? This area. So what will be the area of that picture? So the area of that picture will be the area of the trapezium, right? OABD. So we have to write this area. S means displacement. So displacement will be the area of trapezium. Sorry, we can write like this, OABD, right? Area of trapezium. So we can say that this will be the area of triangle ABC, sum of triangle, sorry, not triangle, there is rectangle, ACDO, right? ACDO. So what will be the area of that ABC? The area of ABC will be the half into base into height. So what will be the half into base? Base means AC, that means that will be T, and the height will be BC. So we have derived that this will be V minus U, and the area of rectangle will be, area means length into breadth, so breadth will be U and the length will be T, so U into T. So from that equation we can write that this will be half into C, this one is V minus U. So from the first equation of motion, that will be V equals to U minus AT. So here from this equation we can write that, sorry, this will be plus, so V minus U will be AT. So from that equation we can use this equation, if this one 1 and this one is 2, so from equation of 2 we can write that V minus equals to, instead of V minus equal to U, we put that AT. So AT is here and this will be UT, right? So there is no space, so I have to okay. Now this will be half A T square plus UT, right? Now S equals to half AT square plus UT. Now we can write that this will be as UT plus half AT square, and here is S. So this will be the second equation of motion. This will be the second equation of motion. See, this one is this. So we have derived that the displacement and time relation. Now we are going to derive the third equation of motion, that is V square minus U square equals to 2AS. So students, now we are going to derive the third equation of motion, that is V square minus U square equals to 2AS. So to do this, we have to know the same equation, that is area S equals to area of the trapezium OABD. So for second equation we are just divide this area into that area of triangle and sum of area of triangle and sum of area of this rectangle. But now we are just calculating the area of the trapezium. So what is the formula of the trapezium to calculate the area? So the formula is half into sum of parallel, that is parallel sides into the distance between the parallel side, okay. So what will be the sum of parallel sides? One parallel, this one is the parallel sides, so one is u and one is v, right? One is v and one is u. And what will be the distance of that parallel side? That means AC we can write, so that will be t. So this will be the area of that trapezium. Now to find this t, we have to move forward that previous equation, that is the first equation of motion. From that equation of motion, we can write that c, that is v minus u equals to at, we know that. So from that we can derive the t, that is t equals to v minus u by a. So we can put this equation into that equation. So half into u plus v, and for t we are putting this, that is v minus u by a. Understand? If this is formula number 3, so we are just writing here that from equation 3, right? From equation 3. So this will be the equation. So what will be the denominator? Denominator will be 2 and a, and u plus v and v minus u. So this will be v square minus u square, a plus b into a minus b, this formula. Now 2 into a comes this side, so it is 2as. S is here, see, s is here, right? So 2as will be v square minus u square. If it is invisible for you, so I write just here that s equals to, see, s equals to v square minus u square by 2a. So for that we can write 2as, 2 will be here, so 2as will be v square minus u square, or we can write v square minus u square equals to 2as. So this will be the third equation of motion. This will be the third equation of motion, right? So now we know that how to derive the three equations of motion. So by this equation of motion we can do any numericals of this chapter. So now we will learn that one type of special motion, that is circular motion. So you know there are so many types of motion, that is that will be circular motion, that can be rotational motion, and periodic motion, and oscillatory motion. So there are many types of motion. So in this chapter we are going to learn the circular motion. So students, now we are going to learn about the circular motion. So what is circular motion? Circular motion is when an object rotates or when an object moves along a circular path, that motion is called circular motion. Just like this, if we suppose this is your hand and you tie a stone with, this is stone, okay, this is stone. So you tie a stone with thread and you hold the thread on the other hand. Now if you rotate the stone, or if you rotate the thread, you will see that the stone rotates around your hand. So if this is, the circle is very awkward, okay, just so see, the motion of the stone will be like that. It will move around a circular path. So this type of motion is called circular motion. In that motion, the velocity is always changes. Because why? Because you can see what is the uniform motion. Uniform motion will be when the magnitude of the velocity and the magnitude and the direction of the velocity will remain constant. But here, if the magnitude, though the magnitude constant, but the direction of the motion is always changes. Like that, if this point, suppose this is A, at that point the direction of the motion is right like this, the tangent of that position, right? That means if you release the thread, the stone moves this way. So the direction of the velocity is this way, right? And now when the stone is here, now if you release the thread, the stone go this way. So the direction of motion is in this way. So you can see that in all positions the direction of motion changes. The direction of motion changes. That means the velocity changes. Though the magnitude can be same, but the velocity is changes. This type of motion is called accelerated motion because the velocity changes everywhere, every point. So this type of motion is called that accelerated motion. And see the direction of acceleration. What will be the direction of acceleration? Here you can think that the direction of acceleration will be this way, but actually not. The direction of motion will be towards the center. This will be the direction of motion, direction of acceleration. Why? Because you see, when you rotate the stone by your hand, you have to give some force to the thread. So the direction of the force in this way, okay, in this way you have to, when you rotate a stone with a thread, you have to give some force in that stone or in that thread. So the direction of the force will be in this way. From the Newton's second law, we can say that the direction of force and the direction of acceleration is same. From that equation, we can say that the direction of acceleration will be this way. So we will run the Newton's law in next chapter. So now we have to memorize this, that the direction of acceleration will be towards the center. That's why it can be called, the motion can be called, or the acceleration can be called centripetal acceleration, because the direction of the acceleration towards the center. Okay, now students see, so what will be the velocity changes here. We just learned that the velocity changes in every point, but what will be the linear velocity or linear speed? What will be the speed of this motion? So speed can be written as the distance per unit time. So here the distance is the circumference of that circle. So what will be what is the circumference of the circle? If the radius is r, that we can write that the circumference will be 2 pi r, and the time, if the time is t, so the speed will be s equals to 2 pi r by t. So by this way we can calculate the speed of that motion. Okay, so that's it. I will give some homework and some notes to you, and some maths solution I will provide through the PDF. And so this chapter is up to this, and from the next day try to take a Google Meet class, and to give you some solutions, I will provide some numericals to you, and you have to do this on the Google Meet classes. And if you have any query, you can ask me through my WhatsApp number, or through my or text me through the WhatsApp number, or you can contact with me in the Google Meet classes also. You can ask me in the Google Meet class. So next day will be the Google Meet class, and day after next day, that will be, I will take a test through Google Forms. Okay, so thank you students for being with me in this video. Thank you.